Hi guys, I am Shashank More and we'll be studying quadratic equation today. Quadratic equation being one of the most important topics of algebra and per se for your competitive examination it is one of the most important topic and year on year you get questions from this topic, so you need to understand the topic from very basic and then we will move on to some higher level competitive questions in our next video. So this video is per se for understanding the basic concept, and by relating to one of the examples I'll explain you how you can understand the concept better. So this is the line of concept, the synopsis of this one. We'll first understand the concept of quadratic equation, what quadratic equation exactly means, what is the standard form of the quadratic equation, and then we will move on to further to roots of the standard quadratic equation, sum and product of the quadratic equation. We will derive the formula of the sum and product of the quadratic equation. Then we will move on to the graphs of quadratic equation. Many times you get the graphs directly in your competitive examination. You need to understand and identify what are the roots of the quadratic equation, what is the nature of the roots of the quadratic equation. So you'll understand that by the graphs. And then further we'll take one example for this. Okay. So we'll start with the standard from the quadratic equation. So first, what is any expression, I would say. So if there is a fx that gives me ax square plus bx plus c. This is an expression. When this expression turns into an equation, when I equalize this thing to a 0, then this thing is a equation. So guys, we need to understand this thing. When 0 was not there or any other constant was not there, it was just an expression. When I equate this thing to 0, then it becomes a quadratic equation. Now why quadratic? Because the highest power of this equation is 2. Hence it's a quadratic equation. So I'll explain you in a bit detail. So this is basically a standard form of the quadratic equation. So if I have to say standard form of quadratic equation, okay? So this is ax square plus bx plus c equal to 0. Coefficient of x square, b is the coefficient of x, c is the constant term. Okay? Will only be a quadratic equation if a is not equal to 0. Okay? So any equation where the coefficient of the squared term, squared variable is not equal to 0, it's a quadratic equation. So here we understand what the basic of quadratic equation is. Now very quickly we'll move on to the roots of the quadratic equation. We'll understand how we can take out the roots, but we'll understand first the formula of the roots of the quadratic equation. So if I say x1 and x2 are the roots of quadratic equation, I would write the formula for x1 and x2 as minus b plus minus under root b square minus 4ac whole by 2a. So understand, x1 will be minus b plus root of b square minus 4ac whole upon 2a, and the another one root x2 would be minus b minus root of b square minus 4ac whole by 2a. Understand, this is from the standard quadratic equation that we have just framed. Our standard quadratic equation was x square ax square plus bx plus c equal to 0. So from this we take out this as the formula for the roots of quadratic equation. Okay. Now so there's one more term in this, discriminant. Okay, b square minus 4ac is often termed as the discriminant of the quadratic equation. Okay, so I may write this in the form of x1 x2 equal to minus b plus minus root of d whole upon 2a. Fair enough? Okay. You can note this down by pausing the video. I just remove this. So guys, we need to understand the concept quickly because we need to also work over the problems of this. Okay. We'll understand this concept more by when we take one of the examples from here. Okay. So now sum and product of the quadratic equation. So now we just saw that the two roots of the quadratic equation were x1 and x2. If I need to find the sum of the roots of quadratic equation directly by my standard quadratic equation, how can I do that? Okay, so I'll again write the standard quadratic equation ax square plus bx plus c. Your exam is sum of roots is minus b upon a. Product of roots is c upon a. So, but we'll understand how this can be derived, and then so it's easy to learn. But if I derive, it will be more easier for you to understand. So I'll derive this for you. The two roots which I just saw were x1 is equals to minus b plus minus under root. Okay, so I'll just remove this minus from here. Root of d whole by 2a. X2 was minus b minus of root d whole by 2a. Okay, so if I do the sum of roots x1 plus x2, very quickly I get minus b upon 2a plus root d upon 2a minus b upon 2a minus root of d upon 2a. Okay, so fairly this and this cancels out. So I have minus 2 times of b upon 2a. This 2 cancels with this one. I get minus b upon a. So this becomes my sum of roots of the quadratic equation. If I need to understand the product of roots now, very quickly I'll just do this product of roots as well for you. Okay. So I have x1 multiplied by x2 as the product of roots. It's minus b plus root of d whole by 2a multiplied by minus of b minus of root d whole upon 2a. So this one I'll write minus b upon 2a plus root d whole by 2a. This is minus b upon 2a minus root of d upon 2a. So fairly you can see, if I take this as p and this as q, this becomes p again, this becomes minus q. Okay, so it's of the form p plus q multiplied by p minus q. We know, guys, this is p square minus q square. So I'll directly pick up this formula and use it here. So p plus q into p minus q gives me p square minus q square. I'll remove this from here. This will give me an identity, that is p square minus q square. I'll write this minus b upon 2a whole square minus q square, that is root of d whole by 2a whole square. Now I need to solve this one as well. I'll remove this from above so that I can have some space to solve this. So this is b square upon, if I do the squaring of this one, this is b square upon 4a square. This is minus of root d, the square of root d becomes d, and then it is 2 to 4a square again. This gives me b square upon 4a square minus, guys, we have the value of d as b square minus 4ac, what we have already studied. So this is b square upon 4a square, b square minus 4ac, so 4ac whole upon 4a square again. Okay, so this terms cancel out with this term, so I cancel this out. I am left with only minus 4ac whole upon 4a square. But I have to carry this minus, where I just forgot. So this is minus of minus, so this becomes plus again. I cancel 4 by 4. I cancel a by a. I am left with only c upon a. Guys, you understood now from where this minus cancel? It was b square minus 4ac. B square minus 4ac when placed here, minus of b square minus 4ac. So this 4ac terms get positive, so minus minus get positive. That's why this one is positive. Okay. So we are left with c by a. So we fairly understand that the sum of roots of quadratic equation gives me minus b by a, and the product of roots of the quadratic equation gives me c upon a. Guys, we need to remember this, because many a times you get the question directly in your examination which asks you the product of roots, the sum of roots. So we need to keep this thing very handy. Okay, now we move on to graph of quadratic equation. So how can I deduce the graph of quadratic equation just by seeing the quadratic equation? It's very easy, but you need to keep things in mind here. So I'll just tell how you can remember this by a standard quadratic equation. So there are two categories of graphs here. One is when a is greater than 0, another one is when a is less than 0. Okay. So how these graphs will be? So we fairly understand that it's a quadratic equation, the power is 2, so the graph will be parabola. That is for sure, we know that. Now how we know the parabola would be upward opening or it would be downward opening? So it's very easy to remember. If a is greater than 0, my parabola would be upward opening. It can be like this, it can be like this, or it can be like this. Okay, so there can be only three category of parabolas here. If a is greater than 0, I may have a parabola which is opening, which is not touching my x-axis. Okay, it may touch at x-axis or it may cut the x-axis at 2 points. So these are the only three categories. So we'll understand how this is. Similarly for the a, if a is less than 0, my parabolas could be like this, okay, like this or like this. Okay, this can only be the three category of parabolas for a less than 0. So I'll explain what further we have for this. If I have a greater than 0 and my discriminant, that was b square minus 4ac, we remember. If my discriminant is greater than 0, then I have a parabola then I have some value in my discriminant that gives me rational roots or irrational roots. Okay, so if my discriminant is greater than 0, I get a graph. Okay, I'll remove the y-axis because it may lie on the left hand side or right hand side of the x-axis. So if d is greater than 0, I definitely have two roots for this, until and unless my roots are imaginary. Okay, so that is not the case because here we are taking d greater than 0, so it can't be imaginary. With d is less than 0, only then in that case the d can only in that case the roots can be imaginary. Okay, so I have two roots here which will give me like this. So this is my one of the roots, this is my second root. Okay, I was using the term x1 and x2 for the root. So this one is x1, this one is x2, and this is my x-axis. Okay, fair enough. If d is greater than 0, I am having two roots. That parabola cuts my x-axis at 2 points, that is x1 and x2, and this x1 and x2 are the roots of the quadratic equation. So guys, you need to remember this, that a parabola, if it's given to you only, and you have a x-axis that is visible and it's cutting at 2 points, these 2 points are the root of the quadratic equation. If d is greater than 0, these are the two roots. If d is equal to 0, then I have a parabola that touches my x-axis. So this is the point where we are having two roots lying. So it could be 1 1, not the point, the root, two roots could be x1 equal to 1 and x2 equal to 1. So it could be any point on the x-axis. If the parabola is touching, the two roots would be at the same point and the roots will be equal. Definitely the roots will be equal in this case. Okay, we have the third case, that is d is less than 0. In this case, the roots are imaginary. What we mean by imaginary, the roots are not existing, or we can use the term I here. So we usually for the CAT per se, we are not using complex numbers as of now. Okay, if once we are studying for complex numbers, we'll do that. Here we'll assume that there are no roots for this quadratic equation. So my parabola would be an upward facing parabola and it won't be touching my x-axis at any point. Okay, fair enough. Okay, so similar lines we study for a less than 0. If I have d greater than 0, I have a parabola that is like this. This would be my x1, this would be my x2. So we took time here to understand for d greater than 0 and for d equal to 0, d less than 0 when a was greater than 0. Because it's on the similar line when a is coming less than 0, only the direction of the parabola reverses. Okay, so this is here, it's cutting at x1 and x2. When it's like this, it's cutting x1 and x2 are equal. And when the third case, there are no roots, so it is a downward opening parabola. It's very small to just see. I'll just remove this. I'll remove for the third case would be, I'll just show you how it will be. So this would be the third case, okay, when a is less than 0 and your d is less than 0. In this case, d is less than 0, okay, b less than 0, okay. I hope you are on the plane till this point. Okay, so now we study a quadratic equation as an example to you. So I'll just compare one standard example for you with the standard equation. So I'll just take this example, what I already written here. This is x square plus 9x plus 20 equal to 0. So this is a standard quadratic equation. Why? I'll just have a quick revision of this. We have a term of x that is having a power square. This makes this equation a quadratic. This expression a quadratic. It's equalized to 0. This makes it a equation. Okay. So what is the coefficient of x square here? We can't see any coefficient. When there is no coefficient in a quadratic expression, the coefficient is 1. So here the coefficient is 1. We usually don't write it here, but it's 1. Okay. I'll just remove it from here. So my A is 1, my B is 9, my C is 20. Okay. So these are the three coefficients which I am having, and these are the vis-a-vis comparison for this A, B, and C. Now we'll understand how we find the root of a quadratic equation. So we studied one formula, guys, but we will also understand one more method. How can we find the roots of the quadratic equation? That's called the splitting of the middle term method. So we'll understand how this method works out, then we'll move on to the formula. Okay. So concept wise, I had to explain this by an example because that is the easiest way to understand this. So that's why I am bringing out an example. Okay. So x square plus 9x plus 20 equal to 0. We'll first understand to find the root of quadratic equation by splitting the middle term. Okay, it's one of the easiest method to understand, but you can't use this always. When you're getting some root or some fractions, it's difficult to use this method. That's why we learn the second method as well, that is that is minus b plus minus under root d whole by 2a. So that one is easier in some cases, but this is also, you should keep this one as well handy with you. Okay, so what we do, what does this middle term term means, and how we need to split it and how we need to use it further. So just tell you how it works. So this is the middle term, okay, this 9. So the coefficient of x is the middle term for me. Okay, I have to, it says splitting the middle term, so I have to split the middle term. How I need to split that, I need to understand first. Okay, so what I first do, I see what is A cross C. Guys, remember A is 1 here, B is 9 here, C is 20 here. Okay, so first I see what is A cross C, that is A into C, that is 20 into 1, it's 20 here. So I need to find out two numbers such that their summation is 9 and their product is 20. I need to see such. So A plus C is 20, A cross C is 20. I need to find out x1, not x1, I'll name this P and Q. I need to find P plus Q gives me 9, that is the middle term, and P cross Q gives me 20. Okay. So this you can solve it by another method. I'll just do this one very easily. I can see that 4 and 5 could be the two options here. It's one of the easiest ones. So I'll just take it directly. My 4 plus 5 gives me 9 and 4 cross 5 gives me 20. So these are my two terms. So what I was telling guys, we have to split the middle term. I'll just put this 4 and 9 as the splitted part of my middle term. So I get the equation as x square plus 5x plus 4x plus 20. What's the use of splitting this middle term? Guys, we need to combine two terms here, okay? And once we combine this, we'll get two factors that will equate to 0, and that will give me my final roots value, okay? So here I combine these two terms and these two terms. It gives me x common, x plus 5. Then I get 4 common, it's x plus 5 equated to 0. How we combine this now? X plus 4, x plus 5. So we combine this term with this term. We take out this term as common. So these two terms has to be same. Okay. So by splitting the middle term, we effectively get these two terms common, and hence we are able to take this out common in this expression. This is equated to 0. So either of one has to be 0. So x plus 4 could be 0. Or x plus 5 could be 0. So my two roots are minus 4 and minus 5. Okay, so these are the two roots of this equation, guys. This is the splitting the middle term method, but I'll just check whether my answer is correct. I'll just write my x1 equal to -4, x2 equal to -5 here, and then I'll try to understand whether why my this thing equation is my answers are correct or not. So I rub this. This was more about the splitting the middle term method. Okay, now I take my formulas as x1, x2 given as minus b plus minus root of b square minus 4ac whole upon 2a. Okay, I'll take my minus b is 9 minus 9, so plus minus root of b square is 9 and the 81 minus 4ac, 4 into a is 1 into c, that is 20, so 4 into 1 into 20 gives me 80 whole upon 2a, 2a is 1, so I write 2 directly, 2 into 1, that gives me minus 9 plus minus root of 81 minus 80, that gives me root of 1 whole upon 2 minus 9 plus minus root of 1 is 1, so upon 2. So two things I get from here, that is minus 9 plus 1 upon 2, that gives me minus 9 plus 1 is minus 8, minus 8 upon 2 is 4, that is minus 4, cos minus 9 it was there, and minus 9 minus 1 whole by 2, this gives me minus 10 upon 2, that is minus 5. So my roots are again coming as minus 4 and minus 5. So this was the second method, guys, the formula method. We need to remember both the methods. Sometimes this one is handy, sometimes that one is handy. To save time, basically we use the middle term method, and if the expression is quite complex, we use the formula method directly. Okay. So x square plus 9x plus 20. So we understood the basic concept what this equation was, a, b, c. We understood the root of standard quadratic equation. We understood the roots by two different methods. One was splitting of the middle term, second was formula method. Now we understand what is sum and product of roots. Guys, we can easily see that sum of these two roots are minus 4 plus minus 5. That gives me, or it is minus 9. So sum of this equation is minus 9, and product of this equation is 5 4s are 20, minus minus multiplied gives me positive, so it is 20. So the formula which we have already derived, sum of the roots of the quadratic equation is minus b upon a. Minus b is minus 9 upon a is 1, so minus 9 upon a is minus 9, so this is correct. Second, product of roots is c upon a, that is 20 upon 1. This is product of root is 20. So this one is perfectly taken. Okay. So I'm just explaining you the basic concept. So what we took before and how the formulas and the roots matches. I'm just explaining you so that you can understand it better. Okay. Formula for standard quadratic equation from sum and product. Okay. So this I think we have missed out. We'll now understand what the formula first. Okay, so I'll just explain you how the formula for the standard quadratic equation can be built by the sum and the product of roots. Okay, so we will come back from here to building up this equation again. So the standard quadratic equation can be built up as x square minus sum of roots into x plus product of roots. Guys, this was very easy, so we can just take it by example. I'll rebuild the quadratic equation that is written here by just using the root. So this is just for remembrance. You can just remember this one, x square minus sum of the roots into x plus product of roots. Okay. X square minus sum of roots is minus 4 plus minus 5 gives me minus 9. So minus 9 I keep here. This gives me x plus product of roots is 5 4s are 20, minus minus multiplied gives me plus. So 5 4s are 20 equal to 0. So this is x squared plus 9x plus 20. This is my quadratic equation. Am I right? Yeah, I am right. Okay. So this is my quadratic equation. X squared plus 9x plus 20. This, guys, we need to remember x squared minus sum of the roots of quadratic equation into x plus product of roots give me the standard form of the quadratic equation, that is ax squared plus bx plus c. I remove this now. So we studied the graph in the last. So what the graph of this equation would be? X square plus 9x plus 20. Okay. So guys, let me do this by seeing the roots of quadratic equation. I have minus 4 and minus 5 as the roots of quadratic equation. If I just take a y axis here, I have 1, 2, 3, minus 4. Then I have a minus 5. I see that this is the coefficient of x square is 1 here, which is a positive term. So my parabola has to be upward opening. So I am sure of that my parabola is like this. And then I have two roots which I can easily deduce. Also by discriminant method we can say that d is equal to b square, that is 9 and the 81, minus 4ac, that is 4 to the 80, into 1, that is discriminant is 1, that is a positive number. So if d is greater than 0 and a is greater than 0, I have an upward opening parabola that cuts the x-axis at 2 points that are the roots of the quadratic equation. So two roots of the quadratic equation are minus 4 and minus 5. So my parabola will be like this. So this is my parabola for this standard quadratic equation. Good enough to go? Okay. So we have studied one example, we have studied the concept of the quadratic equation, we have studied how we can find out the roots of the quadratic equation by two methods. One is splitting in the middle term, another one is formula method. We have understood sum and product of the roots, we have understood how to build a quadratic equation by sum and product of roots, and we have also understood the graphs of quadratic